Good morning, students. In this video, I will be discussing on what is framing and also what is bit stuffing and byte stuffing, or we can say bit-oriented protocol or a byte-oriented protocol. So first, let us see what is a frame. This is the structure of a frame format, which we have already seen in while discussing the OSM model. So every frame will contain three fields. One is nothing but the original information, that is the payload that it is carrying, and also it will contain an header that will contain the source and destination address, and there will be a trailer that contains the mechanism for error detection and correction. So normally we are using CRC 32, that is cyclic redundancy check 32 uh, for error detection. Okay, this is the structure of the frame. Okay, so there are two types of frames. One we call it as a fixed size frame. The other one is the variable size frame. So whereas in case of fixed size framing, the size can be used as a delimiter. Means, for example, whenever the sender is sending some data to the receiver, so I can say that every frame is contains 10 bits. So the 10 bits itself is the indication of one frame with the another. For example, if the first bit is started, once the 10 bits are completed, then the first frame is completed. Then it is the indication that the second frame is started. Then again, bit 1 to bit 10, the protocol will just count all the bits. Once the 10 bits are completed, the second frame is completed. Like that, the size itself indicating the starting and ending of the frame. Okay. So there is no need for defining the boundaries because the size itself is the boundary. So normally fixed size frames we are using in ATM networks. Okay. So coming to variable size frames, in variable size frames, we need to define the end of the frame and the beginning of the next frame because the protocol should identify when the frame is started and when the frame is ended because each frame will be of variable size. The first frame may be of 10 bits, the second frame may be of 20 bits. Then when the frame is started, when it is ended, so there should be some identification or the indication or a delimiter, okay, to differentiate one frame with the another. So in order to differentiate those variable frames, we have two approaches. One we call it as a character-oriented approach. The other one is bit-oriented approach. Normally, we are using this character-oriented approach, a concept known as byte stuffing. Whereas the bit-oriented approach, we are using a concept known as bit stuffing. So using those byte and bit stuffings, we can easily identify the frames, one frame with the another frame. So now let us see one by one. So first let us see the character-oriented approach. So as we already know that the frame format of the frame, say for example, every frame will contain the header as we already seen, which contains the source and destination address. It will contain the trailer that contains the error detection mechanism. And this is the original information. That is nothing but a payload. But here the question is, what is the size of the payload? That is what I am saying, variable number of characters. So in order to identify one frame with the another frame, means first frame with the next frame, we need to use some delimiters. Here the delimiters what we are using is nothing but a flag. Since I am saying character oriented, the delimiter should be an English characters. Okay, so there should be one starting flag that indicates that the frame has been started, and there should be one more flag that indicates the end of the frame. Once the frame is ended, then again the next frame will again start with the delimiter flag. Then there will be an header, then the characters will start. Means original information will be taken one by one until it finds the flag. Once it finds the flag, that is the indication that the second frame is ended. Then again, the third frame will start with the delimiter flag. Like that, with the help of flags, the protocol will identify when the frame has been started and when the frame is ended. Okay. So that's what here the data is carried in 8-bit characters from ASCII technique. So as I already told you, the header will carry the source and destination address, along with that some control information also it will carry, whereas the trailer will carry the error detection and correction mechanism techniques. Okay. So the very important thing here is that to separate one frame from the next. Okay, we are using an 8-bit flag. That's what here. It will be of 1 byte. Okay, or 8 bits flag that added at the beginning as well as at the end of the frame. So this is the beginning of the frame and this is the end of the frame. Okay, hope so you understood. But here the big problem is, so think that you added one flag at the beginning and the protocol will wait for the next flag that indicates the end of the frame. So as per our concept. But in your original information, this is what your payload. In your payload, if there is any uh, information like flag, like my Indian flag is very great. Okay. So the moment when the protocol started picking up the characters, so the moment when it finds flag, then the protocol wrongly indicates that this is the end of the delimiter or end of the flag, sorry, end of the frame, because the starting flag is identified as the starting delimiter, whereas the next flag will indicate the end of the frame. But it is not actually the delimiter at all. It is one of the valid characters in the payload. So now, in order to avoid that, so what you can do, if your information contains the characters like flag, then in order to skip that as the delimiter, to consider that it as a original information, then before that flag, you need to add what is known as ESC, escape. So what I mean to say, you should write like my Indian flag is, sorry, my Indian, instead of writing flag, you should write first ESC. My Indian ESC flag is very important. Then what happens? The flag will be escaped as a delimiter, means it is considered as your original information. Okay, so that flag will be printed now as the original characters, but escape will not be printed. Please keep in mind. So if you want to print even escape, means your information is having like my Indian escape flag is very great. Escape is also your original information. Flag is also your original information. Then again, what you should do? Again, you should type like ESC in order to escape this one. Again, you should write ESC in order to escape this flag. So like that, if you want to escape the original information, not to consider as a delimiter, then prefix you need to add it as a escape, ESC. So in that way, you need to add some extra bytes. That's why we are calling it as byte stuffing. So however, while printing at the receiver side, this escape will not be printed, which we are using as a escaping flag. Okay. So if you escape like this, no, it will be go on printing those characters, flag, escape, everything. So the moment when it finds the one more flag, means the original delimiter, then that is the indication that the flag, the frame has been ended. So in this way, with the help of starting and ending flag delimiters, we are going to identify the length of the frame. Since we are adding some extra bytes here, we call it as a byte stuffing. Okay, but here the problem is, see, if your information contains flag and escape much of the data frequently, then what you can do, instead of using flag as the delimiter, you can use some other characters. It is not recommended that you should always use flag, FLAG. You can use any characters, but say that those characters should not be frequently available in your original information or the payload. Such type of characters, you need to pick it as a flag, okay, as a delimiter, whatever it is. So hope I understood. So this is one small example. See here, my information contains flag as well as escape as the payload. So what happens now? The frame is started. Means this is the flag that indicates the starting delimiter, that this frame has been started. Then the header, the source or destination address. Then the flag is coming as the original information. So now we should not consider this as the end of the frame. So what we should do, before this flag, we need to add what is known as ESC. So we are going to stuff some extra data here. Similarly, here you can see this ESC itself is your original information. So what I need to do now, I should not consider this as the special delimiter. This is for original information. What I should do, I need to print this information. So what you can do, again, you need to add ESC before this ESC. Then it will print flag as well as escape will be printed in the receiver side and trailer and flag. This is what now the frame will carry to the receiver. But at the receiver side, however, this escape means it will not print, only flag will be printed. Even this escape will not print, this escape will be printed as the original information. So here we are stuffing the data, means we are adding some extra data. Here we are going to unstuff, means we are going to remove those extra data which we added. And only flag and escape is printed. So in this way, and lastly, the flag will be coming, which indicates that it is the end of the frame. So in this way, the byte stuffing will work. So here I've given one point. Byte stuffing is the process of adding one extra byte, nothing but a flag or any other special characters whenever there is a flag or escape character in your text. Okay. So hope you understood. So as I similarly told you, we have one more concept known as bit-oriented protocol. So the concept is same, but instead of working with characters, we are going to work with the bits. So here the same thing. Now the flag, which is used as the start date delimiter or a starting frame, should be represented in terms of zeros and ones because we are dealing with bit-oriented protocol. So this is what 1 byte, where we are representing 0, 5, 6 ones and 0. Okay. Starting delimiter, and this is the ending delimiter. And the header will contain again the source and destination address. Trailer will contain the error detection mechanism. And this is what our original information that contains the data in terms of bits. Okay. Same thing what I told will have. But here the problem is, in case if your original information again contains the sequence of bits like 0, 7 ones and 0, so then mistakenly the protocol will identify that it as the end of the frame. So in order to avoid that, again you need to add some escape characters here. So what you can do, whenever in your payload, if you find 0 followed by 5 ones, not even the 6 ones, okay, 0 followed by 5 ones, then immediately you need to add one more extra 0 that acts as the escape character, or that skips that adds the delimiter. Say for example, here you can see most protocols use a special 8-bit pattern flag as the starting and as well as one more flag at the ending. But here, as a question, as I told you, in case if your original information contains this pattern, it should not mistaken it as the end of the frame. So for that, what you should do, in your original information, if you find like 0 followed by 5 ones, like this is what your information you think. So actually, this is the indication of end of the frame. But that is what your original information actually. So what you should do now, whenever there is a 0 followed by 5 ones, 1, 2, 3, 4, 5, immediately you should add one 0. So that will skip that as the original information and it will print as a payload rather than indicating it as a delimiter, end delimiter. Okay? So here is a simple example. So this is what the original data what the sender is sending 100011. If you see here for example, here, 0 followed by 7 zeros and 0. So this is actually your flag bits 0, 1, 1, 1, 1, 1, 1, 1, 0. So this is the starting flag. The moment when it finds this in the original information, the protocol mistakenly identifies that this is the end of the frame. So in order to avoid that, what I told you, 0 followed by 5 ones. Here you can see 0 followed by 5 ones. Immediately we need to add one 0 here. That is what we call it as stuffing. Okay. And even here also 0 followed by 5 ones. I added one extra 0 here. Okay, here I added. This is what an extra bit I am adding, and here also an extra bit I am adding. These are the two extra bits here and here in order to escape that it has not a delimiter. So once it is done, then the last one more flag will be there with the 0, 7 ones followed by 0 that acts as the end of the frame. So this is what the frame will receive at the receiver side. So the moment when it is printing on the application layer, what it will do, means with the upper layers, it will just remove those extra bits which is added. We call it unstuffing. And remaining data will be printed to the next layer. That is what upper layer, network layer. So this is where we are adding one extra, two extra bits or any number of bits at the center side, and we are removing those bits at the receiver side. That's why we call it as a bit stuffing and unstuffing. So this is how the bit stuffing and the byte stuffing concepts will help in identifying the length of the frame in case of variable size framing. Hope so enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.